In this video, we will solve a question on Cobweb model. The question is, the demand and supply functions for Cobweb model are given as quantity demanded at time period t is a function of the price that is prevailing in the period t, so which is equal to 19 minus 6 pt, and quantity supplied in the time period t is a function of the price that is prevailing in the earlier period, that is 6p subscript t minus 1 minus 5. We have to find out the intertemporal equilibrium price and the nature of equilibrium. Options are being given. We need to find out the correct option. This question is related to what we call the difference equations. We have a Cobweb model, that is quantity demanded at time period t is a function of the price that is prevailing in this period, okay, but the quantity supplied in time period t is a function of the price that was prevailing in the earlier period, okay. That is, let us suppose quantity supplied in 2024 is a function of the price that was prevailing in 2023. It makes sense if we take the example of the agricultural products like wheat, okay. So supply of wheat, okay, its supply will depend upon the price that was prevailing in the earlier period. Why? Because production of wheat takes time. It takes, almost 9 or 10 months to produce wheat. So it is not an instantaneous thing that we you know sow the seed and reap it in 1 or 2 months. So there is a time lag in the supply of the tea, quantity supplied and the price of the wheat. So it is not like babnetar medam. That's why we have here this time lag. So what we are being told, we have to find out the intertemporal equilibrium price and the nature of equilibrium. How do we solve it? Very simple. Let us say, first thing is we will equate quantity demanded, and let me write it here. Quantity demanded at time period t with the quantity supplied at time period t. Okay, we equate these two equations, and to equate them it is very easy. So we have 19 minus 6 pt is equal to 6 pt minus 1 minus 5. We need to solve this equation for pt, okay, which implies minus 6 pt will be equal to, transposing this minus 19, it will become minus 19. So we will get 6 p t minus 1 minus 5 minus 19. So solving this again, minus 5 and minus 19 will become minus 24. Minus 24, when we divide both sides by minus 6 and minus 6, what will we get? We will get pt is equal to minus pt minus 1 minus, so we are dividing with minus 6, so minus and minus will become plus, so we will get here plus 4, okay. That means when we solve, that is when we write 19 minus 6 pt, when we equate it with 6 pt minus 1 minus 5, and when we solve for pt, we will get pt will be equal to minus p t minus 1 plus 4, okay. And let me rub this out here. This equation is actually our first order linear difference equation, okay. This is our first order linear difference equation. By difference equation, what we mean, a difference equation expresses a relationship between dependent variable, okay, and a lagged independent variable, okay. So we say this is first order linear difference equation. It is our first order because we have a greatest time lag of one period, so t and t minus 1. There is one difference between the lag. It is linear because all the variables are raised to the power 1, okay. How do we find out the solution of a first order linear difference equation? And let me write it here. Suppose we have a general equation. Let me write it here. Yt is equal to byt minus 1 plus a, okay. If this is our first order linear difference equation, its general solution is being given by, that is yt, and let me write it here. Yt is being given by, yt will be equal to, that is equal to the initial condition y naught minus a upon 1 minus b, okay, times b raised power t plus a upon 1 minus b. Okay, the solution of this general solution of this first order linear difference equation is being given by this very thing. Okay, here this, if we write yt is equal to, let us suppose it is equal to a, this stuff, we have bt, and let us write a upon 1 minus b, it is equal to c. Okay, now this first term denotes the complementary function, and this c denotes the particular solution. Okay, by particular what is this particular solution? This expresses the intertemporal equilibrium level, what we need to find it here, find in this equation. And what is this complementary function? Complementary function represents the deviation from this from that intertemporal equilibrium. Okay, and to find out whether we have the stability in this, in this equation, in this model, stability will require that as time tends to infinity, okay, a b raised power t tends to 0. As time tends to infinity, if this expression, if this if this term vanishes, then we say it is dynamically stable. Okay, now the stability will depend upon this b. The value of b will depend, decide the stability here. Okay, actually I have explained the Cobweb model in a detailed manner in the earlier videos. You can check out the playlist by name differential equations, there you will find. Okay, I will not go into further details here because of the time constraint. So we write this equation in this fashion. So in place of a we have 4. Okay, so let us suppose it is a. The coefficient of p subscript t minus 1 is here minus 1, so let's denote it by b. Okay, now using this equation we can write it, that is pt will be equal to y naught. So we don't have the initial condition, we write here p naught minus a is 4 upon b, so 1 minus, then we have b is minus 1 here. Okay, raise power b is again minus 1, raise power t plus 4 upon 1 minus minus 1, which sums up to, and let's write it here. Let me see if I have the space to write this stuff here. I don't have the space here, so I can rewrite it in this fashion. Pt is equal to, let us do one thing, or let's solve it. So we have p naught minus 4 upon 2 will be minus into minus is plus, so we will get 4 upon 2 is 2, and let's write it here 2. Then we have minus 1 raised power t plus we will get 2. Okay, so using this analogy, let us say this term denotes a, so we have a, this minus 1 denotes our b raised power t plus this 2 denotes c. Let us say this is equal to p subscript t. So this is our time path. As I have told you, this c denotes the particular solution, what we call the intertemporal equilibrium. So our intertemporal equilibrium price will be equal to the value of c we got here 2. So intertemporal price is, let me write it here, p dash, so p dash is equal to 2. Now we need to find out whether we have to find out the nature of equilibrium, whether we have the stable equilibrium or unstable equilibrium. All depends upon the value of b. As I have told you, as we will have dynamically stable equilibrium only if, as time tends to infinity, this term vanishes. Whether this happens in this case or not, let us see. Okay, so here if we see b is equal to minus 1, so we have minus 1 raised power t. Okay, actually I don't have the space here to solve all this stuff, so for this let me rub this out. There are certain conditions for stability. First condition is that if the modulus of b is greater than 1, then time path explodes. So we have unstable equilibrium. Time path explodes. If the modulus of b is less than 1, we say time path is convergent. Okay, and since we got the value of b is equal to -1, and when b is equal to 1, and let me write it here, when b is equal to -1, what happens then? When b is equal to -1, in this case our bt will oscillates between +1 and -1. Okay, we will get uniform oscillation. Okay, by this what we mean, as I told you, there are different types of equilibrium or different types of oscillations, whether explosive oscillation or dampened oscillation or uniform oscillation, all depends upon the value of b. If b is equal to -1, which is the case here, our time path will oscillate between +1 and -1, and let me explain it here why. Okay, so for this let me rub this out. If we draw, let us say we have time period here, okay, and here we have bt. What happens since bt is equal to, so in place of bt we have, what we have, -1 raised power t. Okay, so when t is equal to 0 here, when t is equal to 0, what will we get? When t is equal to 0, time period is 0, what happens here? -1 raised power 0 is equal to anything raised power 0 is 1. So when time is time period is 1, we get, sorry, when t is equal to 0, bt comes out to be 1. Let us say this is 1. Similarly, when t is equal to 1, so we will have -1 raised power 1. So -1 raised power 1 is -1. So first we will get like this, then we will go down, so -1 sign. So let us say this is -1. So when t is equal to 1, when t is equal to 1, we get bt is equal to -1. Similarly, when t is equal to 2, we will get -1 raised power 2. So we have square of an negative number is positive. So when t is equal to 2, we get bt is equal to 2. Okay, and similarly you can see we will be oscillating between +1 and -1. So hali harant parishan will be our time path. So we will not converge to a stable equilibrium here. The thing that I want to make clear is here, given this model, the intertemporal price came out to be 2. Okay, and we will get here a uniform oscillation. Okay, uniform oscillation.